The last thing we're going to look at is section 10.2. So we're going to finish up solving systems. We're just going to learn another way to solve systems. It's kind of based on elimination, but it's a very organized way to do elimination. It's very, very, very structured. You don't really have choices. Like yesterday we could say, all right, we'll pick equations 1 and 3, and we'll try to get rid of x. You know, you don't have any choices like that. You're going to do this, then this, then this. So some people don't like that it's more structured because you have to follow a certain process. Now, I'm not going to do this example 1. This would have been a review of the way we did it yesterday. It's probably going to take like 10 minutes to just go through the way we've already done it. So I'm going to do this problem, but I'm going to do it with a matrix. So I'm just going to talk about what matrices are, and then we'll come back and actually do this problem. All right. All right, so we're going to use a matrix. So a matrix is basically just a fancy way of saying you have a container that you can put things in, right? You can think of a matrix as like an ice cube tray. An ice cube tray has rows in it, and it has columns in it. And you can put things in those rows and columns. Usually you put water, but you could put a marble. You could put Hershey Kiss in each one. You can put whatever you want, okay, in the ice cube tray. In our tray or matrix of stuff, we're going to put numbers, okay, because we're going to be solving systems. So the way you describe a matrix is to describe how many rows and columns it has. So if you said to someone, I have a 2 by 3 matrix, 2 by 3 means 2 rows, 3 columns. Rows are horizontal. Columns are vertical. We have to go with that. Now, if you make a matrix and it has the same number of rows and columns, that's called a square matrix. That would be like 3 rows, 3 columns, 3 by 3. So since we're going to be dealing with a matrix that has rows and columns, those are pretty much two-dimensional. Okay? Just like an ice cube tray, rows and columns. Matrices technically they can be one-dimensional. I'm going to show you an example of that. They can also be three-dimensional, four-dimensional. Right? You can make it as many dimensions as you want, but we're going to focus on 2. So the entries or the individual things that you put in a matrix, those are called the elements. And elements can be different things: numbers, letters, words, objects. Depends what you're using your matrix for. Okay. Another name for a matrix, and you see this name more when you do like programming, is an array. Okay, you call it an array. So when we want to reference a specific element in a matrix, this is the notation that you use in math. Okay? You put a lowercase letter and then row, comma, column as a subscript. So this means what's in row 2, column 3 in the A matrix. Row 2, column 3, right there, the number 9. If I was doing this in the specific computer language that I showed you, it would be like this. A bracket 2 bracket 3. That's how you write row, column, at least in C++. Every computer language is different, just like real languages. Right? So this is how you kind of do it in math language. And then this is how you do it in for a name. Now, I don't like using just a single letter for a name, okay, if I'm actually doing a computer program, because when I look back at that 6 months from now, I'm going to have no idea what A means. So that's why you saw in my program, I named my array math department. So when I look at it, I can say, oh, well, it's the math department, so I know what it is. If I just called it Q, when I look at it, I probably wouldn't remember what that means. So when you program stuff, you try to name things so it makes sense. But in math, we're not really associating it with a word problem, so we can just use a single letter because these numbers don't have any real meaning. Okay. So the convention in our book is capital letter to name a matrix, small letter to reference an element in it. So the main advantage here is it doesn't really save on the number of steps. What it saves is how much you have to write at each step. And you still have kind of a lot to write, but you're just not going to have to write any more letters. Okay, we're just going to write numbers through the whole problem. So let's say you had just kind of a simple system of equations. So if you had that system and you wanted to write it as a matrix, what we're going to do is focus on the coefficients. 2, -4, 3, -5. And you would do something like this. 2, -4, 3, -5. We should start with that. We still got to deal with the 8 and the 9, but we'd start with those 4. Each column in that matrix represents a particular letter. The first column was my x's. The second column, my y's. Okay? You have to line the variables up. That's important. Okay? And what I wrote right here, this is called the coefficient matrix because it's a square matrix of all the numbers that were in front of the letters, the coefficients. Now, what we have to do is we also have to put numbers on the other side of the equal sign. So the way we do that is we go like this. We put in a vertical line, and that just means, okay, whatever's to the right of that line was originally on the right side of the equation. To the left was the stuff on the left. So we augment. Augment means to add a column or a row, in this case a column. So we augment the coefficient matrix with the numbers that were on the other side of the equation. Okay, and that's the first step. Okay, we've translated what we had as an equation just into a matrix of numbers. Any questions on that idea? What the coefficient matrix is, or augmenting it with that column to the right? Okay, so now we don't really care about this column on the right as far as when we start to do arithmetic. What we want to focus on is these numbers, okay? And even more, I'm going to show you what you have to focus on there. But you're going to focus on just the stuff that's on the left. And the goal is that you want to transform that coefficient matrix so you have ones on the main diagonal. The main diagonal is considered the one from the upper left to the lower right. So ones on that diagonal and zeros everywhere below. However many rows and columns you have, you want zeros everywhere underneath the ones. What you're essentially doing is each time you create a zero, you're getting rid of a variable. And the more variables we can get rid of, the easier it's going to be to solve the system. Till eventually you get to a point when you get to the last row, everything in the last row is going to be a zero except one of the variables. So that last row is going to help you to get your first variable because it's only going to have one number in the whole row. Everything else is zeros. Okay. Now the name of what this kind of matrix is called, you get ones on the diagonal and zeros below it. This is called row echelon form, which from now on I'm just going to abbreviate REF. Now, with matrices, you can also take it a step further. We're not going to do this part. We're going to do it a little differently. But you can also then get zeros above the diagonal. If you get zeros below and above, that's called reduced row echelon form. Okay? If you don't want to get the zeros above it, that's okay, but then you got to do something different at the end, which for us is going to be substitution. If you wanted to avoid substitution, you could do what I just said. Get the zeros up here as well. Now, to get a matrix in row echelon form, you are only allowed to do three things to it. There's three operations that you can do on a matrix. And only these. These are it. One thing you are allowed to do is you can swap any two rows you want to swap. So you can swap two rows. And the symbol that I'm going to use for swap is this. So when you see a double-ended arrow, that's going to mean to swap. And they would put numbers here. If you saw like a 2 and a 3, that would mean swap rows 2 and 3. Okay, so we can swap two rows. We can also multiply any row by a number. Now, we kind of did that yesterday. What operation for what method for solving systems did we do something like that in? Where you'd multiply an equation by a number. Yeah? Elimination. So this is right from elimination. You can multiply a row or an equation by any number except 0. And you can also add one equation to another. That's also from elimination. Right? We added up the columns. We're doing the same thing here. We can multiply an equation by a number and then add it to another equation. Now, when you see me write a number and I circle it, that's going to represent row number whatever. So a number circled, it's not arithmetic, it's just a symbol for row 2, row 3. Okay? Double-ended arrow means swap. When you see a single arrow, that's going to indicate where to put a result. So if I had a bunch of arithmetic here, and then I did this, that would mean do whatever calculation I just wrote and put the answer in row 2. Okay? So an arrow is just telling you, okay, after you do your calculation, write your answer here. You got to put it down somewhere. Okay, and from now on, elementary row operations, I'll just call them EROs. Okay. So, you're going to see this direction on the test, so I'm just going to write it so you know what it means now. So the process of getting a matrix in row echelon form using the elementary row operations I just described. So the process of getting a matrix in row echelon form using elementary row operations is called Gaussian elimination. What are you eliminating? You're eliminating numbers and turning them into zeros. That's what you're doing. You're getting rid of numbers that are already there and turning them into zeros. So if you see the directions in the book or on the test, and they say, solve the following system using Gaussian elimination, that's what we're going to do. That's coming up next. Now, the extension to Gaussian elimination is Gauss-Jordan elimination. That's when you get the zeros below the diagonal and above. We're not doing the second half of it. We're just doing the first half. Zeros below, and we're going to finish off with substitution. All right, so we're not really solving this again. This is the first time solving it. but I'm going to do this as example 2. So I'm going to come back to that one. And I'm going to start with one that I think is a little easier, example 1. Okay, so the first step here is to translate all of this into a matrix. If I wanted to write down the first equation as row 1 in my matrix, what numbers would I write? And there's a reason why this one is a little easier, and it's kind of because of what's happening right here. Yep.
Like 1, 0, 1, 4?
Yep. 1, 0, 1, 4. All right, so we can start with that. What would my... Now, this technically isn't one of the rules, and you don't have to do this, but you could write down row 2 the way it is right now. Or there's actually something you could do right away. You want to see what you could do to row 2? And it's not a big deal if you don't. You're going to get the same answer. Yeah?
You divide by 2?
Yeah, you could. Well, technically division is not a row operation.
Oh,
so you'd have to say that a little differently.
You could multiply a row by a non-zero constant, such as 1/2.
Yes. You could multiply everything by a half, and I'm going to do that. So we get x, y, 2, and 5. If you don't do that, is it a big deal? No, it's fine. It's just that's going to be easier. So now, what would I put for my numbers in the second row? Yep.
1, 1, 2, 5.
All right. And what about my numbers in the third row? Yeah. 1, 6, 8, 4. Now, could I have multiplied everything in row 3 by a half? I could, but then I would have half, 3, 4, 2. I mean, half isn't that bad, but if I don't need fractions, I'm going to try to avoid them for now. Okay. Now, I'm going to show you the order that you have to go in. Okay. These, I'm just going to put boxes around the things we're going to focus on. That's the first thing we're going to look at. And I'll tell you what we're going to do in a second. That's going to be the second thing. That's going to be the third thing. Okay, the way this kind of works is you go left to right. You go left to right and you work your way down. So it's like you're working your way down into this bottom right corner until you get to the 8. That's going to be the last thing. So this will be the next thing. Then that. And then that. Those little red numbers are purely steps. Step 1, 2, 3, 4, 5, and step 6. So remember the goal. 1's on the main diagonal. So I want to get a 1 here, here, here. And I want zeros here, here, and there. Okay. So now we're ready to do it. So, first thing I want to do is make sure that I have a 1 in the upper left. What would I have to do in this problem to get a 1 in the upper left? Nothing. There already is a 1. Okay? If it wasn't a 1, I would have to make it a 1 somehow. Like, let's say that the original problem had a 2. I'd say, okay, you could multiply everything by a half. Or, just swap 2 rows. If you swap 2 rows, you could get that 1 up there. But we don't have to worry about that, so that's good. Next thing I want to do is get a 0 right there. What would I have to multiply row 1 by, and then add it to row 2 to make that spot a 0? Yeah? -1. I don't care what's going to happen to this number, or this number. I don't care about them. All I want to do is make that a 0. So the way we write it is like this. You take -1 times the first row, and we're going to add that to the second row. Now, so far, you haven't written anything down. This is all in your head. You have to put that answer somewhere. So where are we going to put it? It's going to replace what's in row 2 right now. So you're going to multiply -1 times everything in the first row, add it to the second row, and that's going to give you the new second row. Now I want to do the same thing here. What would I multiply row 1 by to make a 0 in the first number in row 3? Yeah? -1, just a coincidence this time it's the same. That usually doesn't happen. So -1 times everything in the first row, added to everything in the third row, and that's going to give me my new third row. So row 2 is going to change. Row 3 is going to change. What about row 1? No. Row 1 never changes. Once you get a 1 in this spot, you're going to copy this row down the rest of the problem. 1, 0, 1, 4. You're probably going to end up writing it down like maybe 4 or 5 times. 1, 0, 1, 4. Now, this is the step where, as you're going through it, like if somebody comes and talks to you halfway through you're doing it, you're going to have to start over. Because it just, you're going to kind of like go through it in kind of one motion. So we're going to multiply by -1, add to row 2. What's 1 times -1?
-1.
Plus 1. 0. 0 times -1? 0. Plus 1. 1. Okay. 1 times -1? Plus 2. 1. 4 times -1? Plus 5. 1. Right. And now we're going to do it again. Multiply by -1, add to row 3. What's 1 times -1? Plus 1? 0. 0 times -1? 0. Plus 6? 6. All right. 1 times -8? I'm sorry, 1 times -1? -1 plus 8? 7. And lastly, 4 times -1? Plus 4? 0. Now, don't write this part down, but just look at what you have. Row 2 basically says this. 0x plus 1y plus 1z equals 1. Row 3 says 0x plus 6y plus 7z equals 0. We got rid of the x's. That's what we just did. Now all we have is this. 2 equations, 2 variables. So we started with 3 and 3. Now we're down to 2 and 2. And we're going to do this one more time, and then we're going to be down to 1 and 1. 1 equation, 1 variable. And then we'll have one of our answers. Okay, so we've got that, we've got that, we've got that. That's the next step. In step 4, what number do I want to get right there? I want to get a 1. What do I have to do to my matrix to get a 1 where I just click? This time, nothing. The next one we do, you're going to have to do something. Okay? But this time, it's already a 1. So we're good. Now we go down to the next one. 5th number we're going to focus on. What number do I want to get in the 5th step right here? Yeah? Well, we want row echelon form. So what does that mean? It means these numbers here and these numbers here. Yep.
You want it to be 0?
I want it to be a 0. 1's on the diagonal, 0's below. So now, how would you get a 0 in this spot? What equation would you have to multiply by, and what number would you use? Yep.
You could multiply the second one by -6.
Yes. -6 times the second equation. So far, that's still in your head. Add it to the third equation. And if that's all you do, you haven't written anything yet. Now, tell me where you want to write it. We're going to put that result in row 3. So what's going to happen to row 1 here?
It's going to stay the same.
It's going to stay the same. What's going to happen to row 2? It's going to stay the same. Okay, rows 1 and 2 are done in this problem. We're just going to copy them over. 1, 0, 1, 4. 0, 1, 1, 1. Now, this is the reason why you have to do it in this order. Once you get a 0 above something, it can never mess up anything below it. Because what's 0 times negative 6? 0 plus 0. Stay 0. If you hadn't got a 0 above that spot first, you would have just messed up this 0 right here. Like if this number was a 2, you would have had 2 times negative 6 is negative 12. And then when you added it here, you would have messed it up. So that's why we go in that order. Right? What's 1 times negative 6? Negative 6 plus 6. 0. Now one more. 1 times negative 6 plus 7. 1. I lied. One more. 1. It's the same calculation. 1 times negative 6 plus 0. Negative 6. Okay. So now we just did that one. Now step 6. What number do I want in the lower right-hand corner of my matrix? A 1. What do I have to do to this matrix to make that number a 1? Nothing. It already is. So what does that last row tell me? It tells me technically 1z equals negative 6. There's your first answer. What does this second row tell me if I wrote it out with letters? Y plus, what letter is it? Z. Z, right? Y plus z equals 1. But we know z. Z is negative 6. So fill it in. Y minus 6 equals 1. So what's y? 7. And now what does the top row tell me? If I write it, let's write it out in letters first. Yep. X plus z equals 4, and z is negative 6. So x minus 6 equals 4, x equals 10. Yep. And that process was called Gaussian elimination. We're going to do the same process one more time, but it's not going to be quite as nice. Like we had a lot of things we didn't have to do. Like we just ended up with a 1 here. We ended up with a 1 here. Like that's not going to happen the next time. Right? So I'm going to use a calculator anywhere we have fractions, just to make it easier. But you will still get nice answers. Okay? And the problems on the test, I'm pretty sure they have nice answers too. So there's not crazy decimals and fractions. Questions on that one? All right. So let's try this one. Now, as we go through this one, I'm going to do it using the exact same method I just showed you. If I was doing it, there's going to be a point where I would do something different than what I'm going to show you. But it's a trick to kind of be clever, and I think if I show you that, it's just probably going to be more confusing. So I'm just going to brute force, go through it exactly the same way, even though to me it's not the most efficient way to do it. All right, so let's write this as a matrix first. What would my first row be? Henry?
1, -2, 1.
Yep. And Trish, how about my second row?
2, 3, -2, -3.
2, -3. Right. And Jacob, my third row?
1, 3, -2, -2.
All right. So I'm not going to write down the steps this time because there's 6 numbers there we need to change. Which one do I focus on first? Just tell me what row and column it's in. Yeah. Okay.
Row 1, column 1.
Row 1, column 1. Yep, we're going to focus on that number. And we want to turn that number into what number? a 1. So what would I have to do to make row 1, column 1, a 1? Nothing. That's about the only nice thing that's going to happen here. So that's already a 1. So what's the next thing I want to focus on? Yep.
Row 1, column 2.
Row 1, column over here? That's row 1, column 2.
Sorry, I guess, row 2, column 1.
Yes, row 2, column 1, right?
And now columns are up and down.
Columns are up and down. Yep.
Yeah,
So now, what do we want to make that number? 0. So can anyone tell me what would you multiply equation 1 by to make that a 0? Yep. -2. So -2 times row 1. And what row am I going to add that to? Yeah.
Row 2.
I'm going to add it to row 2. And so far, you've just done a bunch of math in your head. Where are you going to put that answer as you do it? It's going to replace what's in row.
Well, I have a question.
All right, let's just write that down first so we don't lose our train of thought. Where's that answer going to go? Row where? 2, yes. Okay. Question before we keep going.
Can you, so like to get the numbers where they're supposed to be like the ones and the zeros, can you only like multiply to rows that are already done? So
You only want to use a row that's above you to fix what's below.
But it doesn't have to be directly above?
It doesn't have to be directly above, but it has to be above.
Okay.
If you use a row that's below to fix one that's above, you're gonna mess things up. You got to work your way down and to the right, down and to the right. Okay, so now we want to get a 0 here. What would you have to multiply row 1 by to do that? Oh, Sebastian? Not sure? Well, yeah, you want to multiply this number by something, so it's the opposite of this number. That's the goal. So you said multiply it by -1. Yeah. So we're going to do -1 times the first row, and we're going to add that to what row?
3.
Yep, I'm going to add it to row 3, and that's going to replace what's in row 3. This is the only step where you're changing 2 rows at the same time. Okay, every other step after this, it's 1 row at a time. And you can break this out into 2 steps, but then you're going to copy everything twice. And the more you copy it, the more likely something's going to go wrong. Okay, what's going to happen to row 1? Nothing. Row 1 is going to be the same from now to the end of the problem. It's never going to change. 1, -2, 1, -1. Okay, now let's go through. -2 times the first row, added to the second. 1 times -2, plus 2, 0. -2 times -2, 4 plus 3, 7. What's 1 times -2? Plus -2? -4. And one more. -1 times -2. 2 plus -3. -1. Okay. Now, next calculation. -1 times the first row added to the third. Okay, 4 times. What's 1 times -1? Plus 1. 0. -2 times -1. 2 plus 3. 5. All right. 1 times -1. -1 plus -2. -3. One more. -1 times -1. 1 plus -2. -1. Any questions on that stuff? So you're doing like, whatever you do to one column, you have to do it every single way, all the way down each column. Multiply by a number, add it here. Multiply by a number, add it here. Multiply, add. Multiply, add. That's what you keep doing. Okay. So now we turned our system into 3 equations and 3 variables. Now we're down to 2 equations, 2 variables. What's the next thing that I want to focus on? What row and what column? Joe? Row 2, column 2. And what do I want that number to be? A 1. Yeah. And it's a 7. So what could I do to make this number a 1?
3 times the first row.
Remember, you can't use... if you multiplied that by 3, you would have to do it here too and add it here. So it would mess up that 0. So we don't want to use the row that's above it. Yep. You have to multiply row 2 by 1/7. Now, that's not exactly the way I would do it, but that's the way we're gonna do it. So we're gonna multiply 1/7 times row 2. Now, my method that I would use, I would still have a fraction, but I would only have a fraction with a denominator of 2. And to me, that would be easier than a denominator of 7. But let's just do it this way. So all we're going to do is multiply everything in row 2 by 1/7. Row 1, just copy it. 1, -2, 1, -1. Now, what's 0 times 1/7? 0. What's 7 times 1/7? 1. What's -4 times 1/7? Alright, that's kind of annoying, but we'll deal with that. And what's -1 times 1/7? -1/7. Right. And the last row, we just copy it over. 0, 5, -3, -1. Okay. Now, what's the next number we focus on now? Row, column what? Yep.
Row 3, column 2.
Row 3, column 2. Yep. And what do you want to do to this number? You want to make it a 0. So you only want to use the row that's directly above. Don't go 2 rows above because there isn't a 0 in this spot. Anything you use this row for, you'd mess these up. So what could you multiply row 2 by? Yeah? -5. So we're going to multiply row 2 by -5, and we're going to add it to row 3. And that's going to replace what's currently in what row? 3. Yep. So what happens to row 1? Nothing. What happens to row 2? Nothing. Just those 2 rows are done for the rest of the problem. 1, -2, 1, -1. 0, 1, -4/7, -1/7. What would really mess you up is if you change those fractions to decimals. Don't round that, just leave it. And now we've got a calculation. 0 times -5 plus what's below it? 0 times -5?
0.
Plus 0.
0.
0. So as long as you do that, there's no way to ever mess that 0 up because what's directly above it is already a 0. 1 times -5? Plus 5. 0. Now, I'm going to multiply -4/7 by what? I'm going to multiply it by -5. Okay, I'm just going to use the calculator. Okay, I'll worry about that after. So I got that. And I'm going to add it to what number? I'm going to add that to -3. So I didn't round anything. The way I can get the fraction is just press math, fraction. And it tells me it's -1/7. Okay? I don't want to get bogged down with common denominators and all that stuff. And now let's do it one more time. Negative 1/7 times what number? Yep. So negative 1/7 times negative 5. And then we're going to add it to what number? Negative 1. Now, just by looking at the decimal, to me, it looks like it's double the one that's above it. So it's probably negative 2/7. Math, it is negative 2/7. Okay, and that's probably the worst calculation. Okay, last thing now, focus on the number row 3, column 3. What do I want that number to become? A 1, because if I make it a 1, my equation would say this. 1z equals, and then I'm going to have the answer. What would you have to multiply row 3 by to make this a 1? Yep. Negative 7. So multiply row 3 by negative 7. Put your answer in row 3, and this is the end of using the matrix. Okay, then we're going to use substitution to get x, y, and z, and that part's really easy. Okay, row 1, 1, negative 2, 1, negative 1. Row 2, 0, 1, negative 4/7, negative 1/7. Now, row 3, multiply everything by negative 7. 0 times negative 7? 0 times negative 7? 0. Negative 1/7 times negative 7. 1. And negative 2/7 times negative 7. That's just going to be 2. Because the 7's cancel, negatives cancel, and all you're left with is a 2. So what does the last row tell me? Yep. Z is 2. Now go back up to the row above it. Y minus 4/7 z equals negative 1/7. But we just figured out z is what? 2. What's 4/7 times 2? 8/7. And how would you move negative 8/7 to the other side? Add it. Negative 1/7 plus 8/7. What's negative 1/7 plus 8/7?
1.
7/7, right? Or just 1. So y is 1. Now, what letter am I missing? X. What row in the matrix would help me get x? It's got to be the top one. If you use the bottom one, x isn't even there. If you use the middle one, x isn't there. You've got to use the top one. Can somebody just read the top row to me in letter form? So yeah, 1x minus 2y plus z. All right, and now fill in what we got. X we don't know. What's 2 times 1? 2. Z is 2. Negative 2 plus 2, what happens? That's gone. We get x is negative 1. Okay, so it's really just doing elimination. You're just getting zeros like we did yesterday, but it's a very particular structured way to do it. The way I've showed you, you're always going to get z, then y, then x. That's the order you go in. Okay. Now, where some people get tripped up is all of a sudden I give them a 2 by 2, and then they get confused. But the 2 by 2 it's way faster than the 3 by 3. If you had something like this, I'm not going to go through and solve that. But what element do you focus on first? Yep. Row 1, column 1, and you would want this to be a what?
1.
Already is. What would you focus on next? Yep. You'd focus here next and make that a what?
0.
A 0. And now you'd be at the last step. Your last step would be to focus on what number? Yeah. Row 2, column 2, and what would you want that number to be? A 1, done. Okay. So you always work left to right and down. Okay. So a 2 by 2 would be much, much, much faster. I don't know what that comes out to, I just made that up. So we did that one. Okay, so when you solve a problem with a matrix, the same type of thing can happen yesterday, and we've already done it. So I'm not going to look at it again with a matrix. But you can get no solution, and you could get infinite solution. If you ended up with something like this, do you think that that would be no solution or infinite solutions? That's no solution, because you ended up with 0x plus 0y equals 5. How can 0 times something plus 0 times something equal 5? It can't. It's basically 0 equals 5. That's what would happen in a no solution. Okay? You get a false statement. Now, what do you think that one would be? That's infinite. Because now you're saying 0x plus 0y equals 0, or 0 equals 0. So in a matrix, that's the equivalent of the special cases we did yesterday. Okay, but we're not going to spend any more time on that. Okay, so any questions on that? Okay, so it's a little bit different, but it's a very organized way to do it. And no matter how big of a matrix you ever gave me, I would always, like if I had something like this, the general goal, get a 1 here, get a 0, get a 0, get a 0, get a 1 here, get a 0, get a 0, get a 1 here, get a 0, get a 1 here. Okay, I didn't put the last row, but it would be the exact same approach every single time, Susan.
So like on the test, like if you give us one like that has 3 of all thingies, like can we just choose whichever one we want to do? Or like are you going to tell us to do it the way we did yesterday, or?
For the 3 by 3, at least one of them is going to say use Gaussian elimination. Yep. So it'll be the way we did today. For the other one, it'll probably be one where you can pick. You can do it any way you want. Okay. With the 2 by 2, those are a little quicker. I think I have one that says substitution, one that says elimination.
To do it this way, is there going to be a time where none of the equations have a 1 for the first variable?
Yeah, like this one doesn't have a 1 for the first variable. Yeah, the easiest way to do that would just be switch rows 1 and 2. Done.
But will there always be an equation that has a 1?
With the kind of problems that I'm going to give you, yeah.
Okay.
So all you'd have to do is switch rows 1 and 2. If you really didn't want to switch the rows, you could multiply this row by a half. So then you're going to have half x, or x minus a half y equals 0. So half is not an awful fraction to work with, but still a fraction. Okay. Any other questions? All right. So homework 1 through 6. Those aren't even actually like full problems. It just says like what would you multiply row 2 by to make it cancel row 3. So all you have to do is say like I would double it or I would triple it. So those ones are really quick. 17 and 18, those are 2 variables. 21 is a 3, but I'm going to get rid of one of them. I forget which one I got rid of in the other class. Get rid of that one. And I know we got rid of 32. So it might be one problem different than the other class, but it's the same amount of problems. Okay, so 1 through 6, 17, 18, 24, and 31. Don't forget, I will be after school today.